Imagine Alice, a software developer in Austin, Texas. Her small startup, CodeCraft, uses AI to help businesses build custom mobile apps faster. For months, she's relied on a subscription to a leading proprietary AI model, paying roughly $2,000 a month just for its API access. It helps with generating code snippets, debugging, and even drafting documentation. But every time she wants the AI to understand a full client specification, spanning dozens of pages, or review an entire codebase for vulnerabilities, she hits a wall. The AI's memory, its context window, is too short. It forgets half the project before she's even finished explaining the other half. This is the common reality for thousands of developers, powerful AI, but with invisible walls around its true potential. Then on July 16, 2026, a company called Moonshot made an announcement that shook the artificial intelligence world. They had released Kimi K3. This wasn't just another incremental update. Kimi K3 arrived boasting 2.8 trillion parameters, a 1 million token context window, and native vision capabilities. Early independent reviews, like those from the Silicon Valley AI Lab, immediately placed it at the frontier level for agentic coding. But here's the truly astonishing part, the one that makes your ears perk up. Moonshot announced Kimi K3 as an open-weight model, and its full weights landed publicly on July 27, 2026. This means, unlike the proprietary giants, you can download and run this massive, state-of-the-art AI on your own infrastructure. I dug through the technical papers and the economic implications so you don't have to. The question isn't just what Kimi K3 is, but how a model of this scale can be both open and, for all practical purposes, free to operate at a fraction of what you'd expect. It comes down to a fundamental shift in AI architecture and a bold strategic move by Moonshot. To understand Kimi K3, we first need to grasp what 2.8 trillion parameters actually means. Think of a neural network, the engine behind AI, as an incredibly complex, multi-layered mathematical function. Parameters are the numbers within that function that the AI learns and adjusts during its training process. They are the model's memory, its understanding of patterns, language, and logic. The more parameters an AI has, the more complex relationships it can potentially learn, and the more nuanced its responses can be. For context, Google's original Transformer model in 2017 had about 213 million parameters. OpenAI's GPT-3, released in 2020, had 175 billion. The leading proprietary models of 2025 were estimated to be around 1.7 trillion parameters. Kimi K3 at 2.8 trillion isn't just bigger, it represents a new scale entirely, packing in more learned knowledge than any open-weight model ever released before. Now about that free part. This is where open weight becomes critical. In the world of AI, there's a spectrum of accessibility. At one end, you have truly open-source models, where not only the final weights, but also the entire training code, data, and methodology are made public. At the other, proprietary models like those from OpenAI or Google are black boxes. You can use them via an API, but you never see the underlying brain. Open weight falls in the middle, and it's a game changer. It means Moonshot has released the actual numerical values that constitute Kimi K3's learned knowledge. These are the millions of gigabytes of data that are the AI crucially. This allows anyone to download the full model, run it on their own servers, fine-tune it for specific tasks, and integrate it into their applications without paying per query fees to Moonshot. This isn't just open source in spirit, it's open source in practice, making frontier AI accessible to everyone from independent researchers to small businesses like Alice's startup, CodeCraft. This move directly challenges the traditional business model of large AI companies, which typically involve licensing access to their powerful models. For years, only tech giants with immense resources could afford to train and host models of this scale. They could then charge developers for every interaction, creating a significant barrier to entry for smaller players. For example, a 2025 estimate from the AI Economy report found that running inference on a large proprietary model could cost a startup with moderate usage tens of thousands of dollars annually. By releasing Kimi K3 as open-weight, Moonshot bypasses this gatekeeping. Suddenly, the computational power needed to run a leading AI model becomes a capital expenditure for hardware, rather than a recurring, usage-based bill. This allows innovators to experiment, build, and deploy without being beholden to a single provider's pricing structure or policy changes. But downloading a 2.8 trillion parameter model is one thing, running it efficiently is another. This is where Moonshot's chosen architecture, a mixture of experts, or MOE, becomes the secret to Kimi K3's practical accessibility. Imagine a vast library with nearly 900 highly specialized librarians, each an expert in a tiny niche of knowledge. When you ask a question, the head librarian doesn't send every single one to research it. Instead, they quickly identify the 2 or 3 most relevant experts, who then work together to find your answer. That's essentially how MOE models work. Kimi K3 has 896 individual experts, but for any given input, only about 16 of them are activated and used to process the information. This selective activation is crucial. While Kimi K3 has a staggering 2.8 trillion total parameters, only a small fraction of them are actually in play for each piece of information it processes. This dramatically reduces the computational load and, consequently, the cost of running the model. A dense model of comparable total parameters would require activating all 2.8 trillion parameters for every single token generated, demanding immense memory and processing power. With Kimi K3's MOE design, the effective number of parameters processed per token is closer to 50 billion. This means that running Kimi K3 for inference, that is, using it to generate text, code, or images, is orders of magnitude cheaper than what a dense model of its headline size would imply. According to a July 2026 technical analysis by the OpenAI Collective, Kimi K3's inference cost per million tokens is comparable to that of a 70 billion parameter dense model from 2025, which represents a massive leap in efficiency for its capabilities. Beyond its sheer size and efficient architecture, Kimi K3 also boasts 2 other game-changing features: native vision and a 1 million token context window. Native vision means Kimi K3 can see and understand images, diagrams, and video frames directly, without needing separate, specialized models to interpret them. This allows it to process complex visual information alongside text. Imagine feeding it an architectural blueprint and asking it to flag inconsistencies, or showing it a user interface design and having it generate the corresponding code. The 1 million token context window is equally revolutionary. A token is roughly equivalent to a word or part of a word. A million tokens means Kimi K3 can hold a massive amount of information in its working memory at once. For comparison, most leading models in early 2026 had context windows of around 128,000 to 256,000 tokens. This expanded memory allows Kimi K3 to analyze entire novels, long technical manuals, or vast code repositories, holding the entire scope of a project in its mind without losing track of details. These combined capabilities, massive parameters, efficient MOE, native vision, and a million token context, are what make Kimi K3 frontier level for agentic coding. Agentic coding isn't just about generating code snippets. It means the AI can act as an autonomous software engineer. It can receive a high-level goal, break it down into smaller tasks, write the necessary code, debug its own errors, test its solutions, and even iterate based on feedback, all within a single, continuous process. For Alice at CodeCraft, this means her AI assistant can now be given an entire client brief, including wireframes and user stories, and return not just isolated functions, but entire working components of an application. This drastically accelerates development cycles and fundamentally changes how software is built, making the promise of AI-driven development a tangible reality for a much wider audience. So why would Moonshot give away such a powerful model? This isn't charity, it's a strategic move in a rapidly evolving market. By making Kimi K3 open-weight, Moonshot aims to establish its model as the de facto standard for developers. They forego direct-to-API revenue in favor of building an ecosystem. Developers who build on Kimi K3 might eventually pay for Moonshot's specialized cloud infrastructure, for training even larger custom models, or for premium support and enterprise-grade fine-tuning services. It's a play to become the foundational layer of the next generation of AI applications, much like Linux became the foundational operating system for servers, despite being free. This strategy challenges incumbents like OpenAI, which primarily monetize through API access, by offering a powerful alternative that democratizes access to cutting-edge AI. The release of Kimi K3 as open-weight marks a significant turning point in the AI landscape. It represents a tangible step towards democratizing access to frontier AI capabilities. Smaller companies, academic researchers, and independent developers no longer need multi-million-dollar training budgets or exclusive partnerships to work with the most advanced models. They can download Kimi K3 and immediately begin innovating, pushing the boundaries of what AI can do without the constraints of per-token costs or restrictive licensing agreements. This could lead to an explosion of new AI applications and services that might never have seen the light of day under a purely proprietary model. Kimi K3 is more than just a large language model. It's a statement about the future of digital systems. It suggests that the most powerful AI tools may not always reside behind paywalls, but could become foundational public utilities, much like the internet protocols themselves. This open-weight approach accelerates innovation across industries, from scientific discovery to creative arts and especially software development. The invisible systems powering our digital lives are becoming not just more intelligent, but also more accessible, shifting power from a few centralized entities to a global community of builders. The decision by Moonshot to release Kimi K3 as a 2.8 trillion parameter, open-weight model with efficient MoE architecture fundamentally changes the economics and accessibility of frontier AI. This means the most advanced AI capabilities are now, for the first time, truly within reach for anyone with the hardware to run them. Subscribe to Loopback, and the next video is waiting for you on screen right now.